Okay, number 8. Start with your numbers. 18 divided by 6. What is 18 divided by 6? 3. Next, we look at our x's. X to the 3/4 divided by x to the 1/4. When we are using exponents, if we're dividing with the same base, we subtract our exponents. So 3/4 minus 1/4 is 2/4, which is 1/2. So we have x to the 1/2. Now our y's. He's just kind of chilling by himself. So we just leave him there. And now the z's. Z to the negative 1/3 over z to the 2/3. So z to the negative 1/3 minus 2/3. If you can't do that in your head, which is fine if you can't do that in your head, grab your calculator, negative 1/3 minus 2/3. You end up with z to the negative 1. Can I leave my answer like that? No. So not only can we not have radicals on the bottom, we also can't have negative exponents. So the 3x to the 1/2 y stays on the top, and z goes to the bottom. Okay, number 9, I would like you to try number 9 on your own. I think that you can do it. Remember, mistakes are proof that you're trying. Mistakes help you learn and improve, so don't avoid writing something down because you're afraid you're going to do something wrong. Try something. If you're stuck, a good place to start is writing this all out with the 4th root of 12, the 4th root of d to the 4th, the 4th root of e to the 9th, the 4th root of f to the 14th. So spread it out so you have some room to do something. 4th root of 12. I would look in my fourths column, but unfortunately there aren't any numbers smaller than 12 that we could break it into. So the 4th root of 12 is pretty much, I mean, it's simplified. There's no perfect fourths in there. The 4th root of d to the 4th. Exponent divided by index, that is just d. 4th root of e to the 9th. Some of you can picture division with remainders fairly easily. So 9 divided by 4, you can even try that in your calculator. 9 divided by 4 is going to be 2. There's 2 groups of 4 with 1 left over. Or if you like dots, 1, 2, 3, 4, there's 1 group of 4. There's 2 groups of 4, that's 8. So there's 2 groups of 4 with 1 remainder. Or split this into the 4th root of e to the 8th, the 4th root of e, so you can physically see there's 8 and 9 e's. This is e squared, 4th root of e. Same thing for f to the 14th. We need groups of 4. If you really like the dot method, there's 1 group. That's 8. There's 12, 13, 14. So it's going to be f cubed times the cube root of f squared. These two would still be left under the radical. Or split it up into the 4th root of f to the 12th times the 4th root of f to the 2. So you can see the 12 and the 2 makes 14. 12 divided by 4 is 3, so f to the 3rd. All right, arranging our answers. We start with the stuff that's not under the radical. So d, e squared, f to the 3rd. Then we find all of the stuff left under the radicals, numbers, then letters in alphabetical order. So draw in a 4th root, 12 e f squared. And there's our final answer. Okay, if you are a super planner, you might look at number 10 and think, oh hey, on the bottom, that's h to the 7th on the bottom, and I need groups of 5 in order for the radical on the bottom to be gone. So it'd be really nice if that was h to the 10th instead of h to the 7th. So you could basically rationalize the denominator before you've even gotten started. If you don't notice that, you'd have to wait until the end. So I'm going to do this once rationalizing at the beginning and then once rationalizing at the end. If you rationalize at the beginning, you've got the 5th root of g squared and the 5th root of h to the 7th. I would really like it if that h to the 7th was an h to the 10th. And I can get that by multiplying in the 5th root of h to the 3rd. So now on the top I have the 5th root of g squared h to the 3rd over the 5th root of h to the 10th. On the top, 5th root of g squared. There's not a group of 5 there. They're going to be stuck under the radical. 5th root of h to the 3rd. There's only 3 there, not 5. They're going to be stuck under the radical. On the bottom, if you do exponent divided by index, that's going to end up being h squared. So our answer is going to be the 5th root of g squared h to the 3rd over h squared. That's rationalizing at the beginning. That's planning forward and saying, hey, this h to the 7th is going to be problematic. Let's fix it now so we don't have to worry about it later. If you don't do that, you would say on the top we've got 5th root of g squared. On the bottom, I know there's one full group of 5 that's going to break out, and there's going to be 2 left over. Now, problem, I have a radical left on the bottom, so I'm going to multiply by the 5th root of h to the 3rd to complete my group of 5 on the bottom. And now on the top, we have the 5th root of g squared h to the 3rd. On the bottom, we have the original h, and this creates another h, so we have h squared. It doesn't matter which method you use to get to your answer, either rationalizing first or rationalizing at the end. Okay, are you ready for something a little bit easier now? Take a look at number 11. This is basically what we did yesterday. Notice you have square root of s, square root of s, square root of s. What number could we put in front of that last square root of s? A 1. Since the index and the radicand are all the same, they're all square roots of s, we've got 6 minus 2 plus 1. What is 6 minus 2 plus 1? 5. 5 square root of s. Are you really, really hoping I put that one on the test? Like really, really? I'll see what I can do. Well, I can't make every problem like that because that wouldn't be testing. But yes, I will probably, I'll try to put a problem like that on there. Okay, number 12. Do you see a problem with number 12? Are the radicals the same? No, the first one has the 4th root of 6x to the 5th. So over here on the side, I'm going to take the 4th root of 6x to the 5th and see if we can simplify that radical at all. I notice that inside x to the 5th, that's 5 factors of x, there's one full group of 4 with 1 left over. So this would become x on the outside, 4th root of 6x. So I'm going to replace this piece with this piece. 2x times the 4th root of 6x plus x times the 4th root of 6x. Now you might notice the x 4th root of 6x matches the x 4th root of 6x. It's a slightly more complicated like radical, but because it's both x 4th root of 6x, you can do 2 plus 1 to get 3x 4th root of 6x.